morning everyone. In today's lecture we are going to discuss about converter. So in previous lectures we have already discussed that what is your dual converter. So we have discussed about converters, and converters are it may be your AC to DC converter or DC to DC converter. In previous lectures we already discussed about AC to DC converter, in which we discussed about rectifiers and single phase converter, three phase converter, and we discussed about your different type of converters like bridge converter, midpoint converter. So and we already discussed about your waveforms of different type of converters. So you have already done about single phase and three phase converters and different type of three phase and single phase converters. In this lecture, we will discuss about dual converter. Okay. So learning objective and outcome of this lecture is that I'm expecting from student after this lecture, they will be able to understand the principle of working dual converter. They will be able to understand the waveform of dual converter, and they will be able to understand the different kind of waveforms of dual converter and their advantages and disadvantages, and what are the applications of dual converter. So let's start with introduction of dual converter. So dual converter is an electronic device or circuit made by the combination of two bridges. One of them work as a rectifier which convert AC to DC, and another one is uh, another bridge work as a inverter, and it converts DC to AC. So it is an electronic device. It has two circuits, or you can say two bridges. One bridge convert from AC to DC, and another bridge will convert from DC to AC. So the bridge which is working as a AC to DC is called rectifier, and the bridge which is converting from DC to AC is called your inverter. So an electronic device, it has two converters, and in an electronic circuit or device in which two processes take place at a time is known as dual converter, because simultaneously you are converting from AC to DC. After that, at the same time, it is converting from DC to AC. So two processes are working at a time. That's why this is called your dual converter. Now, what is the basic principle of dual converter? So you can see in the diagram that there are two converters. One is your D1 and another one is your D2. Converter 1 and converter 2. This is your DC terminal voltage. Alpha 1 is the firing angle for the converter 1, and alpha 2 is the firing angle for converter 2. Now, so we are taking assumption that dual converter is ideal and they produce pure DC output terminal. As in the figure, each two converter is assumed to be controlled direct voltage source connected with a diode, and diode D1 and D2 is representing that they are unidirectional, because diode can work only in forward biasing. When this terminal is positive and this terminal is negative, then diode will conduct the current. Otherwise, it will not conduct, or you can say if this terminal is negative and this terminal is positive, diode will be in reverse biasing. So this diode will not be conduct. Okay. So the you can say that there are two diodes D1 and D2, which is representing the unidirectional current flow and the characteristic of the converter. The current in load circuit can, however, flow in only one direction from this direction to this direction. Current can't flow from this direction to this direction. So we can say that a dual converter is a unidirectional, means the current direction will be only in one direction, and it consists of two converter. One is converting from AC to DC and another is converting from DC to AC. So one is your rectifier and another one is your inverter. Now let's come to the point, that is your single phase converter. So in single phase converter, you can see in diagram that there are four SCRs in first diagram, or you can say in converter 1, and there in another converter 2 is also four SCRs. So the SCR is your T1, T2, T3 and T4, and another SCR is your T22, T24, T21 and T23. So actually dual converter, it may be your single phase and three phase. So you can operate this dual converter in both phases. It may be your single phase dual converter and it may be your three phase dual converter. So in this diagram you can see that one is your line and another one is your neutral. One is your phase, another one is your neutral. So this is your single phase dual converter. Okay, this is your reactor and this is your motor, and you are getting output voltage which is your EDC, right? Now the difference between the single phase and three phase dual converter is just in three phase we uses three phase rectifier at first stage, while in single phase dual converter we make use of single phase rectifier, which is showing in this circuit. This is your first bridge, this is your rectifier and this is your inverter, and you can see that what is the difference between these two. The direction of SCR is opposite the direction of SCR of converter 2, or you can say the direction of SCR is opposite to each other. The thyristor which is connected in this converter is in upward direction, and the thyristor which is connected in this converter is in downward direction. So as explained above, that in single phase dual converter we use a single phase rectifier for converting single phase AC into steady DC bridge number 1. So number 1 is consist of rectifier. Then the rectified DC, you can see that from this bridge we are converting AC to DC, okay, which is fed into this machine, that we get this much output EDC which is fed into the inverter. So it is converting the DC into the output. So you can say that the rectified DC fed to a filter which removes pulses from the rectified DC and converts it into a pure DC by filtering. After that, this pure DC is fed to the load, and from load it is given to the inverter. So the circuit which convert this DC to AC, and finally this AC of inverter taken as the output. I hope now it is clear to you. Once again, I make you clear that uh, uh, in inverter we are having four SCR and a rectifier, as well as we have four SCR also. So you can see that in converter 1, in this rectifier, you are converting from uh, converting from AC to DC. This DC is fed to the filter. So the AC component of the output of this rectifier can be removed by using the filter, and you get pure DC. That pure DC is fed to the load, and after this load you can see that for this inverter this load is your source. Okay, so the DC, which is your load output, is fed to into the inverter, and this inverter convert the DC into the AC. And you can see that there are four thyristor. Four thyristor never work as simultaneously. Only two thyristor will work simultaneously. I have already told you that this is your positive thyristor, this is your negative thyristor. So at a time, one positive thyristor will conduct and one negative thyristor will conduct at a time. At another waveform, which is your negative waveform, for this thyristor, this thyristor T13 and T14 will be turned on. Okay, so at a time, four thyristor will not conduct, only two thyristor will conduct. T1, T11 and T12 will conduct at a time. After that, for negative cycle, T13 and T14 will conduct. So now this is your three-phase dual converter, in which you can see that we are taking three phases, and instead of 8 SCR, we are using here 12 SCR. Okay, so you can compare both the diagrams and you can easily find out that what is the difference between single phase dual converter and three phase dual converter. So in three phase dual converter, we make use of three phase rectifiers which convert three phase supply AC to DC. You can see that we are feeding three phase supply AC, which is converting into the DC, and the rest process are same. This DC is fed into this motor or load. After this load or getting filtered, this DC is fed to this load, and this DC is the input for this inverter, and this inverter convert the DC into the AC. Okay, so you can see one is your positive converter and another one is your negative converter. And the thing is that one is converting your AC to DC and another one is converting your DC to AC. So one behave like a rectifier and another behave like a inverter. It is same just like your single phase dual converter. So you can see that it do the invert process of rectifier and converts DC into three phase AC, which appears at output. Okay, now the next point is what is a practical dual converter, because the diagram we have seen, that is your ideal dual converters. Now let's come to the point, what is your practical dual converter. So you can see that in practical dual converter, uh, there are firing angles. So the firing angle, you have to adjust the firing angle according what is your desired output. So if the firing angles of the two full converter are adjusted such that alpha 1 plus alpha 2 is equal to 180 degree, and both the converters operate simultaneously, then they will produce the same average terminal voltage, which will be equal to the average DC load terminal voltage. So due to this values of firing angle, one converter will be in the rectification mode and the other in the inversion mode. Because we have done in our three phase converter that if your firing angle is greater than 180 degree, it automatically come into the inverting mode. Okay, So the problem is that we have to focus on our firing angle, and it must be uh, your the sum of these two firing angle must be 180 degree, right? So due to these values of firing angles, one converter will be in the rectification mode and the other in the inversion mode. So however, in the non-ideal dual converter, each converter produce a ripple voltage at the outputs of the two converters are mostly out of phase. So in the way, even though the average output voltage of the two converters are equal, their instantaneous values are not equal. So due to this fact, when the output of the two converters are connected together, the instantaneous voltage difference at the terminal of the two converter will produce a large circulating current between the two converters. So you can see in the diagram. So this current will not flow through the load. It is necessary to control this circulating current by some means to protect the SCR connected in the converter circuits. So you can see if these two converters are working simultaneously, so there may be some, there may be some voltage which can appear across these terminals, this terminal and this terminal. So there may be some, uh, current which can flow, that is called your circulating current. So the problem is that we have to protect this circuit from circulating current. So in the next slide I will discuss that how can we protect this dual converter from your circulating current. So this current will not flow through the load. It is necessary to control this circulating current by some means or to protect the SCRs connected in the converter circuits. So two methods that are normally used to control the circulating current are as follows. One is your operation without circulating current, and another one is your operation with the circulating current. So there are two methods by which you can control the operation or circulating current. That is your operation without circulating current and operation with circulating current. So first we will discuss about operation without circulating current. So this is called your non-circulating current mode. Okay. So in this mode of operation, the flow of circulating current is not allowed at all by operating only one converter at a time. In this mode, the converter which is operating will carry the entire load current. Okay. So at a time, only one converter will conduct and it will carry the entire load current of the circuit. So the other converter will remain in its off state and one converter will remain in its on state. And uh, in this mode, there are no firing pulse are not applied to it because at a time one SCR is conducting. So when one converter is conducting, it will carry the whole current of your circuit. Now you can see that this is the mode where yeah. Next point is your operation with circulating current. So you can see in the diagram that in this mode the circulating current is flowing. So it can also damage our SCR. So protect those SCRs. What we are using one reactor in between these two terminals. Now I will tell you how it will protect. So in this mode of operation, the magnitude of circulating current is controlled below a safe value. This is achieved by connecting a circulating current reactor between the output terminals of the two converters as shown in figure. Now, In this mode of operation, both the converters are turned on simultaneously and the firing angles are adjusted by the control voltage Vc in such a way that alpha 1 plus alpha 2 is equal to 180 degree. So the average voltage produced by both the converters will be same, but their instantaneous values will be different. So if instantaneous value is different, there must be some potential difference, and just because of that potential difference, the circulating current will start to flow. So the circulating current can be limited by using a current reactor. Okay. Now, what are the advantages of this, reactor? That both the converters remain in conduction simultaneously, continuously, irrespective of whether the load current is continuous or not. And the dual converter respond fast if the converter are in continuous conduction. Now, the disadvantage is that you have to use one reactor, and the reactor are costly and bulky at high power levels. If you are using this dual converter for high powers, then the SCR, the reactor which you are using, that is costly and bulky. So this is the disadvantage of your dual converter with circulating current. Now we come to the waveform of this dual converter, single phase dual converter. You can see in the diagram that at a time two SCR will work. So this is your input voltage. At alpha 1 you are going to trigger the SCR. At a time these two SCR will work. For the negative half cycle, these two SCR will work. So you can see that you are getting a converter output 1, which is your DC output, and another one is your AC output, and this is the waveform of your circulating current. Okay. Which is flowing when there is a potential difference between these two these two converters. Okay. If they are at same potential, like this, if they are at same potential, there is no circulating current. When there is a voltage between these two, this is your voltage of converter 1, this is your voltage converter 2, that you are getting, that is your output voltage. Okay. Which is responsible for your circulating current. Now, one converter is rectifying and another is your inverting. So the output of this VDC is equal to 2 Vm upon pi cos alpha, and another one is your inverting. So you can put over here that 2 Vm by cos alpha 1 and VDC2 is equal to 2 Vm upon pi cos d alpha 2, and it must be equal to each other. Keeping these equation equal to each other, you are getting this equation, and you can see that the alpha 1 plus alpha 2 is equal to 180 degree by solving this equation. Okay. Now the next point is your the firing angle. When you are taking some firing angle for this circuit, you can see that the firing angle is your 60 degree, and this is your three phase waveforms. So you can see at a time how much the thyristor is conducting from this diagram. This is your interval, first, second, third, fourth, and fifth and sixth. This is your three phase waveforms. Okay. So R, this is your R phase, this is your Y phase, and this is your S phase, and you can sorry, B phase. So for a three phase waveform, the voltage difference between these three phases is 180 degree. So you can easily draw the waveform by the difference of 180-degree. And we let's start from this first interval. In first interval, you can see that 1 5 means R and Y, and 2 6 means Y and B is conducting. Okay, so you can see from the diagram, which is your three-phase diagram. So these are the positive converters, and this is your negative converter. For three phase, at a time 4 SCRs are conducting, two for your positive mode and two for is your negative mode. So 1 and 5, 1 and 5, 1 and 5 for positive, and 6 and 2 is for your negative. So at a time, two SCR will conduct, and you can identify this from your waveform, that if you take this interval, okay, so you can see for this interval, your this waveform is positive, okay, this waveform is positive, which is connected to your R phase, and another waveform which is your connected to your Y phase, and this waveform, okay, this is connected to your B phase. Okay, so when this waveform is turning on, then you can see for this one is positive and your 5 is negative. Okay, so 1 and 5 will conduct. After this, 2 and 6 will be in your conduction. Okay, at this point, 1 and 2, 1 and 5 is conducting, 1 and 5 is conducting negative terminal. Then for this rest of the region, then your 2 and 6 will conduct. So by small interval, you can easily draw the output waveform, and the output voltage will be RB, means this is your positive and this is your negative. So for this interval, you are getting RB. Now let's come to the second interval. You can see that for this interval, from this interval to this interval, your Y phase is positive and your B phase is negative. So you are getting YB. Now let's come to the third interval. You can see that for this interval, your Y is positive and your R is negative. So you are getting output is your YR. Like this, you can draw the waveform easily. Now you can come to the output of your second converter. According to that, you can also take the waveforms at a time which is positive or which is negative, and you can get the output of converter second. After that, you will get the output voltage, which is like this. Okay, so voltage across the reactor is also showing here. You can see that there must be some voltage which will represent across your reactor. So this is your waveform for circulating current mode. Now, the operation of the dual converter with circulating current is explained with the following assumption, that the reactor is lossless and the firing angle of the two converters are controlled so that their sum is 180-degree. Now, the waveforms for the circulating current mode are as shown in figure. The firing angle for the converter 1 is alpha 1 is equal to 60-degree. Therefore, firing angle for the second converter is equal to 120-degree. Now, because of the circulating current, both the converters are kept in the on state. So, at the no load and with load conditions, hence the voltage waveform are well defined. The supply voltage and the converter output voltage are as shown here. The instantaneous DC output voltage is the average of the instantaneous converter voltages. So this output voltage has a shape different from that of the converter output voltages. but the average value of the output voltage is the same as the average value of individual converter voltage. So the voltage across the circulating current reactor is, you know, different between the instantaneous converter output voltage, which is equal to V01 minus V02. So in a dual converter without circulating current operating mode, the flow of circulating current is completely inhibited through automatic control of the firing pulses. So that only that converter which carries the load current is in conduction, and the other converter which carries the load current in conduction, and the other converter is temporarily blocked. Since only one converter operates at a time and the other is in blocking state, so no reactor is required between the converters. At a particular instant, suppose converter 1 is operating as a rectifier and is supplying the load current while pulses to second converter are blocked. So for the inversion operation, which converter 1 is first blocked by removing its firing pulses and load current is reduced to 0. So converter 2 is made to conduct by applying the firing pulses to it. So you can understand that in non-circulating mode, only one converter will conduct at a time. Another converter will be blocked by removing the firing pulses. And you can see that if your inverter, if you want that your inverter mode should be in operation, then the firing, you have to apply firing pulse to it, and you have to block the converter 1 by removing the firing pulses of all SCR which is connected to the converter 1. So now is it clear that what is circulating and non-circulating modes? Now the pulses to converter 2 are applied after a delay time of 10 to 20 milliseconds, because this delay time is required for reliable commutation of the thyristors in converter 1. Okay. If the converter 2 is triggered before the converter 1 has been completely turned off, a large circulating current will start to flow and it can damage your circuit. So irregular jumps in the level of the DC terminal voltage at the point of current reversal must be avoided in order to achieve a smooth change over of current from one converter to the other. So the firing pulse control should ideally be such that the mean DC terminal voltage of the converter 2 at the instant of current reversal is the same as that of converter 1. So from this discussion, now it is clear that such a mode of operation requires very sophisticated control system. You can't mix up these firing angles to each other, and it is required, you have to uh, take a control system which automatically blocks and unblock the individual converters according with the direction of load current. So this is all about your non-circulating mode. Now, what are the different applications of converter? So dual converters are mostly used at industries where we require reversible DC. Generally, dual converters are used for speed control of DC motors also. So these are the references where you can get the material, study material, NPTEL and PS Bimra of power electronics. So now I want to summarize this lecture, that what is your converter. You know, converter, it may be convert your AC to DC, or it may be convert your DC to AC. The converter which convert it from AC to DC, that is called your rectifier, and the converter which operate in this mode, that is called your rectification. And if the converter which is converting from DC to AC, that is called your inverter, and the mode in which it is operating, that is called your inverting. Now the question is that what is your dual converter? So dual converter consists of two converters and they are connected each other to back. And one if you talk about your single phase converter, then it has four SCR in each converter. So total it has eight SCRs in your dual converter circuit. And one converter will operate like your rectifier and another will operate like your inverter. In three phase converter you have 12 SCRs, and one will also conduct as a rectifier and another will also conduct as an inverter. Now it can be operated in two modes. One is your circulating mode and another one is your non-circulating mode. So in circulating mode what you have to do, you can do one thing, that you have to use some controlling circuit, because at a time only one converter can work. At a time only one converter can work, and you have to block another converter by removing the firing pulse of that converter. So second thing is your when you are using your circulating current mode, so you have to use some reactors. Okay. And what is the reason of this circulating current? As you know that two converters are working simultaneously. So at a one point of one converter and the another at the second point of another converter, there is some voltage difference, and you know when there is some potential difference or some voltage difference, then current will start to flow. At the same potential, current will not start to flow, but it's not your ideal case. So there may be some voltage difference between two converters, and this converter will not flow through the load. It will start flowing through the SCR, so it can damage the SCR. So protecting those SCRs, we are using reactors. Okay, so reactor will save this these converters from your circulating current. Right. Now there are some objective questions which is based on our today lecture. So let's start. Question number one. Dual converter provide two quadrant operation, three quadrant operation, four quadrant operation, and none of the mentions. So it provide four quadrant operation. Already I have already told you that what is your first quadrant, second quadrant, third quadrant, and fourth quadrant. For your knowledge, that first quadrant in which your voltage and current will be positive. In the second quadrant, your current will be negative, but your voltage will be positive. In the third quadrant, both will be negative, and in the fourth quadrant, that your current will positive, but your voltage will negative. So dual converter can operates in four quadrant. Now the next point is your dual converter has uh, two full converter in series, two full converter in series, two half converters in series, and two full converter in anti-parallel, and two half converter in anti-parallel. So you can already seen that in the diagram that we are taking two full converters, okay, which are connected to each other in anti-parallel. So for this question, the C will be your right answer. So it is dual converter has two full converters in anti-parallel. Now let's come to the next point, that what is your the uh, major advantage of using dual converter is that is it cheaply available, it has better power factor, no mechanical switch is required to change the mode of operation. Exactly. The C is the right answer, because you can see that in the diagram that we are using SCR, which is your static switches. Static means they don't have any kind of movable part. So you need not to put some uh, mechanical uh, operations. You need not to do some mechanical operations or put some mechanical switches or any kind of mechanical system to operate this dual converter. It will automatically work, but but you have to set some firing angles according to your requirement. So C is the right answer for that. Now let's come to the next question. So the four quadrant operation of dual converter can be obtained by moving the mechanical lever, adding inductance to the circuit. Actually, four quadrant operation can be obtained by using your uh, firing angles. So by changing the firing angle values, you can easily operate your dual converter mode. Now, fifth question is a single full converter alone can given a four quadrant operation, three quadrant operation, and two quadrant operation. So only single phase full converter will give the two quadrant operation mode. Now next question is if V1 and V2 are the instantaneous voltage of the two converter circuit in the dual converter, then the output voltage is the two converter circuits in the dual converter and the instantaneous voltage of the dual converter is V1 and V2. So the output voltage will be V1 plus V2 divided by 2. Now, a single phase symmetrical semi converter employ single phase symmetrical semi converter employ uh, one SCR and one diode in each leg, two SCRs and two. If you talk about semi converters, so I have already told you that in converters, semi means it will convert only your half wave, whether it is positive or negative, and you have to use blocking the another wave. You have to use a diode. Okay, so one SCR and one diode in each lag is used in symmetrical semi converters. Now single phase asymmetrical semi-converters are employed, two SCR in one leg and two diodes in the other leg. Now, next question is a single phase semi-converter is connected to a 230-volt source is a feeding load is 10 ohm in series with a large conductance make the load current ripple free. Find the average output current for alpha is equal to 45 degree. So you can see that voltage is given, resistance is given, alpha means firing angle is given. So you can calculate this semi-convert the current, average output current by using the formula which is given in the slide, and you will get this is your 17 amperes. Now let's come to the next question that a single phase semi-converter circuit is supplied power to a motor load and the average value of load voltage is 176.72 volt and the RMS value is 219.3 volt. So what is your voltage ripple factor? I have already done in this in the previous lectures. So by using those formulas, you can easily calculate the VRF value, or you can say voltage ripple factor, which is your 0.735. So this is all about your dual converter. If you have any question, you can ask me. Thank you.